Hello everyone, welcome to my channel. Today we're going to be talking about a very important theory that will be related to all of your chemistry questions about the equilibrium, and it actually sets the foundation for solving the equilibrium and figure out where does equilibrium happen and why does it happen. Okay, so that's the thing that we're going to talking about today, which is called the Le Chatelier's principle. So what does the Le Chatelier's principle stand for? Well, it basically stands for whenever you disturb a system at dynamic equilibrium, it will shift the equilibrium in the direction that counteracts the change. Well, it sounds like very confused, right? You have no ideas to how to understand this thing. Well, let's just directly dive into the examples. So, for example, there's an A plus B, will go forward to produce C plus D, or C plus D will go reverse to go back to A plus B. So A plus B, A and B in here is the reactants, and C and D in here is the products. And there's basically three shifters and three factors that will affect that will related to Le Chatelier's principle and disturbs the equilibrium state. So the first thing is the concentration. So there's two ways we think about this. So first, we think about in the reactant side. If you increase the reactant's concentration, the whole system, the equilibrium, will favors the products formation. Well, how do you think about that? So just think about if you increase like A and B, like if you increase A's concentration, which means that in order to counteract this effect, the whole system will decrease the reactant's concentration, which means it will decrease the concentration of A. So if you decrease the concentration of reactants, which means that the product's concentration must be increased, because remember the concentration of reactants and products are always inversely related. So that means the whole systems will shift forward, so shift to the right. So that means that it will favor the products formation, okay? And the same thing as the products concentration. So if you increase the concentration of products, for example, if you increase the concentration of C, and the whole equilibrium will favor the reactants formation, because think about that, if you increase the concentration of C, in order to counteract this effect, the whole equilibrium will decrease the concentration of C, which will decrease the concentration of products. Well, when you decrease the concentration of products, the concentration of reactants must be increased. So in order to do that, the whole equilibrium will shift left, so shift reverse, because in order to do that, we can increase the concentration of reactants and decrease the products. Okay, so let's move on to the second factor, which is the temperature. So if you increase the temperature, then the whole reactants will favor the endothermic reaction. Okay, so this is kind of like a confusing for the first learners. So let's just assume that this whole reaction is endothermic reaction. So endothermic reaction just means that heat is a reactant, which means the heat is on the left side. So if you increase the temperature, which means heat right here, it stands for a reactants, right? So basically you just increase one of the reactants. So if you increase one of the reactants, the whole systems, by counteract the effect of this, will decrease the reactants effect, which means that the products will increase. So in order to increase the products, the whole systems will shift to the right, right? So which means that it favors the endothermic reaction. It will shift far away from the heat, and think about if you decrease the temperature, otherwise then heat right now, it stands for reactants, so which means that you decrease the reactant, and in order to counteract this effect, the equilibrium will increase the reactant, and by increasing the reactant, the products will decrease, so which means that the whole equilibrium will shift to the left, which means it will shift toward the heat, so which means it will favor the exothermic reaction. So just think about that. If you shift far away, from the heat, then it must be caused by the increasing temperature. And if you shift towards the heat, then the temperature must be decreased. Okay, so these two are kind of counterintuitive, but also make sense. So if you can think about the logic inside it, behind it, then you'll definitely understand this concept. Okay, so the last factor is the pressure. So if you increase the pressure, then the whole equilibrium will favor the side with fewer molecules. So how do you understand it? Okay, so for these two, right now we both sides we have 2 moles, so like A and B are 2 moles and C and D are 2 moles. So if I add an E right here, which lets the product side, the right side, becomes 3 moles. So right here, if you increase the pressure, so the whole equilibrium, by counteract this effect, will decrease the pressure, and it will shift the side that has the fewer molecules, which means it will shift to the right. Shift to the left right now. So if you, by the same thing, if you decrease the pressure, then by counteract this effect, the equilibrium will shift to the side with more molecules, which means it will shift to the right, because right side have 3 molecules, which is greater than the left side only have 2 molecules. So okay, so last thing, before we end this video, I just want to draw like a line for you to figure out which one determines what, in what situations should you think about. So this is the reactant and this is the product. So remember, when the equilibrium is shift to the right, it will always favors the product's formation, which means the product's concentration will increase. And because products and reactants are inversely related, the reactants concentration must be decreased. And by the same thing, if the equilibrium will shift to reverse, which means shift to the left, then it will definitely favors the reaction, like the reactants formation, So the reactants concentration will increase, and by the inversely related relationship, the product's concentration must be decreased. So if you think about that, then when you're facing these type of questions, and when you map these type of questions, then if the question given to us, okay, right now I'm shifting one of the reactants concentration, then you will immediately think about, okay, so right now the equilibrium by Le Chatelier's principle, it have to be counteract this effect. So then it will decrease the reactants concentration, which means it will shift to the right, right? So it will favors the product's formation, which means the concentration of products will increase, and the reactants concentration will decrease. So just think about the logic of all of the questions. And these questions are not hard actually, but it definitely requires some logical thinkings. So you have to practice a lot in order to master it, very effectively using this in all of the questions that you face, like in either multiple choice questions or free response questions. So then, but I think free response will probably more focus on how do you find the equilibrium constant and the a reaction quotient, but never mind. So all of these things have to keep in mind. So remember, Le Chatelier's principle overall just means that if you add something that disturbed the before the original dynamic equilibrium, then the whole equilibrium, by counteract this effect, because the equilibrium must have to shift back, the reaction have to shift back to the equilibrium state, right? And right now you are disturbing the dynamic equilibrium state. So the whole systems have to do something to counteract the effect that you add on to the system. So then it have to be shifting to the directions that will counteract this change. Okay, so this is all of the things that I want to cover in this video today, and this is the concept of Le Chatelier's principle. If you understand the definition for it, and you understand there's 3 factors, concentration, temperature, and pressure, will be involved in shifting the dynamic equilibrium for a reaction, chemistry reaction, then you know what I want you to know. Okay, so I hope this video helps you a little bit, you know something from this video. And if you like my video, please subscribe and leave some comments below. I would like to hear your thoughts. Okay, so all of these things are done. I hope you have a great day, and I'll see you next time. Thank you.